Good day, everyone. Welcome to lecture number 16 of this lecture series on Microprocessor 8085. So in lecture number 15, we were discussing about the interrupts, or we can say in lecture 14 and 15, we completed the discussion about the interrupts. Okay. We said what are the hardware interrupts, software interrupts, and many more interrupts. Okay, and basically we discussed about the INTR, this particular interrupt. Then we also discussed about trap, then RST 7.5, RST 6.5, and RST 5.5. So for these four interrupts, we said that these are vectored interrupts. Okay, vectored interrupts means when our microprocessor receives these interrupts, it automatically goes to one particular memory location and then executes the interrupt service routine stored at that particular memory location. Now, regarding this particular interrupt, this INTR, we said that it is a non-vectored interrupt. So that means the processor has to send the starting address of interrupt service routine. And we also said that another way of sending, or we can say the methodology of sending this starting address of interrupt service routine is to insert RST instructions. So these RST instructions, so we know that we have RST instructions from 0 to 7. These RST instructions can be sent by a microprocessor, and every RST instruction specifies one memory address. For example, RST 0 specifies 0000 H address, and likewise others. So this particular interrupt, INTR interrupt, this is used to do the input-output input-output communication. For example, if my device has to send an input data, my keyboard has to send an input. So we will press a key, the interrupt will go, this INTR will go, and based on the key, we can say whether we have to use RST 0, RST 1, or whatever we have to use. Okay, so INTR, we can say that it is used to do input-output communication. Fine. Now, the disadvantage, or we can say the limitation of INTR is, the first limitation is that there is single pin for this. So single pin for INTR, or we can say there is a single pin that can enable IO communication. So I can also say that I can only connect to one device to this particular interrupt, or to this particular interrupt pin. Okay, and that is one important disadvantage, or we can say the limitation of having only single INTR pin. Okay, what I'm saying, what is the limitation? The limitation is that because of it is single interrupt pin, okay, we won't be able to connect multiple devices to this particular microprocessor. Okay, or we can say we won't be able to allow multiple devices to interrupt our microprocessor for input-output communication. Okay, and another limitation is, the second limitation is that using this scheme, we can only insert RST instructions, or sometimes call instructions, but mostly we use RST instructions. So RST instructions can be inserted, and we know all RST instructions point to these memory locations, 00H, 0008H, probably like this. And you can see that these locations are lower order memory locations. And these particular locations are mostly used for sensitive tasks. So let's say I want an interrupt so that I can perform some general task. Okay, using that interrupt, I want to perform some general task. So those general instructions should not be provided in these memory locations, because these memory locations are mostly used for sensitive tasks. Okay, so these limitations, having a single pin for INTR and having the capability of only sending RST instructions, or another limitation is, third limitation, we cannot change the priority of RST instructions. Okay. So that means RST instructions have a fixed priority. RST 7 has the highest priority, then comes the RST 0 at the end. Okay. So because of these limitations, we have to look for some solution. Fine. And the solution that we have been provided is to use programmable interrupt controller. We will see how it is used, and we will discuss one important programmable interrupt controller, that is 8259A. So let's briefly discuss what is a programmable interrupt controller. Okay, so we have this programmable interrupt controller. And as I said, we will discuss this particular controller 8259. So what is the use of this interrupt controller? How it is used? So basically, this is a hardware device. Okay, and this hardware device communicates with 8085. Okay. How it communicates, how it facilitates the INTR pin of 8085, we will look those details in a moment. And what are it, as I said, that it communicates with 8085, and it is used, or we can say it is designed for use with the interrupt signalers INTR. So these interrupt signalers INTR, and it is acknowledgement INTA. So this particular hardware device uses this particular pins, these two pins of microprocessor 8085, and facilitates the interrupting process. And it takes out the limitations of INTR. So what were the limitations of INTR? Limitations was that it is a single pin, so only single interrupter, or we can say only single interrupting device can be connected to this particular pin. Okay, so what it does, this programmable interrupt, first is that it manages 8 interrupting requests. So using INTR of 8085, we can manage only one request at a time. But if we use programmable interrupt controller, this 8259A, we can take care of 8 interrupting requests. So that means 8 interrupting devices can send the interrupts, IO interrupts. Okay. Second advantage is that we can point any, or we can say we can save interrupt service routine at any memory location. Okay, so that means there are no fixed locations for interrupt service routines. So service routine can be stored anywhere. But previously we were that service routines can be stored only at these particular locations. But here we can save interrupt service routine at any memory location. Okay, or we can say that we can point and interrupt a request anywhere in the memory. Fine. But there is one thing that we have to keep in mind, that you can see that how many interrupting requests we can handle. We can handle 8 interrupting requests. So that means there will be 8 interrupt service routines. Okay. And all these 8 requests, or starting address of these 8 interrupting service routines, they are spaced at an interval of either 4 locations or 8 locations. So that means what? If I have stored interrupt service routine in the memory, I can every interrupt service routine can occupy either 4 locations or 8 locations. And how we can determine whether it is occupying 4 locations or 8 locations? We do that using some programming technique. For example, we can save ISR at any memory location. That can also be programmed. So this can also be programmed. What will be the memory location, memory address of interrupt service routine, and what will be the spacing between these ISRs, whether it is 4 location spacing, this 4 location spacing or 8 location spacing. Okay. And the third advantage of using programmable interrupt controller is that we can have 8 levels of priority, because there are 8 interrupting requests, and we can change these priorities. Okay, this is the other advantage. The fourth advantage of using programmable interrupt is 8259A is we can cascade 8259A devices to provide more interrupting requests. So that means, see, let me write it here. So we were having microprocessor, this was 8085. And we said that this microprocessor was having only one pin INTR as a non-vector. But to increase its capability, we connected this INTR pin to another device, which is 8259A. And this was able to provide how many requests? 8 requests, 8 interrupting requests. Now we can add another 8259 is here. We can cascade these 8259, 8259, 8259 with this one. And this will enable us more interrupting requests. So having cascading of 8259A devices, we can provide more interrupting requests. But the we can say the top level, the expandability is up to 16 requests, not more than 16. Okay. So this was the advantage of using programmable interrupt controller 8259A. Okay. And this is, as I said, this was the theoretical explanation how it is useful for, or we can say how it is useful to add this device to microprocessor 8085. Now we will see the complete details of 8259A. That means we will see how we can connect this device and what are the pins of this device, because every device can be connected via pins, and how we can program this particular device and how it works. Okay, so let's do that. So what I am saying, what we have to do, we have to read the complete details about 8259A programmable interrupt controller. Okay, 8259A programmable controller. So as I said, so let me repeat the things again. So first is that it can manage 8 interrupts. Okay, so it can manage 8 interrupts, and managing 8 interrupts is equivalent to having 8 interrupt pins. Okay, but we know that microprocessor 8085 has only one interrupt pin. Okay, there are other interrupt pins also, but those are vectored interrupts and they have one specific job. But for input output non-vector, we have only one interrupting pin. So it can manage 8 interrupting devices. So it is equivalent to having 8 interrupted pins. Okay, and the second, we say we can map interrupt to any memory location. Okay, and also other thing is we can mask some of these interrupts. Okay. And fourth, we can change their priority, their priorities. And we can also set up, we can program whether these are edge triggered or level triggered. Okay, so you have to keep in mind that we won't discuss this 8259A in detail. Detail means we won't discuss how to mask some of these interrupts, how to change their priorities, how to change from edge triggered to level triggered or level triggered to edge triggered. These things won't be discussed. Why we won't discuss it here? Because for this particular device 8259A, this can be used with 8085 processor, and it can also be used with 8086 and 8088. Okay, but we will only discuss some of the concepts that are important in relation to 8085, because this course is related to microprocessor 8085. These things will be mostly used when we use this programmable device with these microprocessors. Okay, so we won't discuss all the details related to this particular interrupt controller in detail, but we will only discuss some of those necessary details which are used for microprocessor 8085. Okay, so you have to keep in mind, because some of you may find many lot of details about 8259A, but those details won't be the discussion of this particular lecture. Okay. So what will be the first job? First job is we will discuss the pin diagram of this device. Okay, pin diagram, and then we will see all its components and their functionality. And lastly, we will see how to program it. We will see how we can program this particular interrupt controller. So let's first discuss about the pin diagram. Okay, so let me first make the pin diagram of 8085, pin diagram, and we will also see its block diagram. Okay. So this particular device, this 8259A, so this is its pin diagram. It has total 15 pins. Okay. So let me write those pins here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14. So these are the pins. Okay. So here, sorry, not 15 pins, it has 28 pins. Okay, sorry. 15, 16, 17, 18, 19, 20, 22, 23, 24, 26. Okay, so these are the 28 pins of 8259A. And what are those pins? So this pin is chip select pin. Okay, this is write pin. This is read pin. Fine. This is D7, D6, D5, D4, D3, D2, D1, and D0. Okay, this is CAS0, CAS1, and this is ground. This is ground, and this is the voltage. This is A0, pin A0. So these are the names of these. Please don't compare these names with the names of microprocessor 8085. They have different pins. These are different pins. Okay. Then we have IR7, IR6, IR4, 3, 2, 1, 0. Then we have INT. Then we have SP or enable. This is SP. Okay. And we have CAS2. 8. These are IR6 and IR5 also. IR4, IR3, IR2, IR1, IR0, INT, SP, and enable. This SP is basically slave program, and EN means enable buffer. Okay, and CAS2. This CAS, these are cascaded lines. So these three pins, CAS 0, 1, and 2. Okay, CAS 0, CAS 1, and CAS 2. These are used for cascading. Cascading means connecting one 8259 to another 8259. Okay, and we won't be discussing about the cascading, so we won't discuss these pins. Fine. Then these pins D7 to D0, these are for data bus, or we can say it is a data bus, and it is bidirectional. Basically, when my microprocessor has to, when this device has to send some data to microprocessor 8085, it can send through these pins, these 8 pins. Okay, and what data it has to send to 8085, we will see that data. Okay, what is that data used for? Then we have these pins, RD, pin and write. These are for reading and writing. Okay, A0 pin, we will see the functionality of A0 pin. This is also called a command select address, or this is also called a address pin, command selected address. Then CS pin, this is chip select. Okay, and then SP pin and enable pin, these are slave buffer and enable, slave program and enable buffer. Then we have INT. INT is interrupt output pin. And then we have INTA. This is interrupt acknowledgement. Then we have IR0 to IR7. These are interrupt request inputs. Interrupt request inputs. So these are the pins and their names. What are the names of these pins? Now we will make the block diagram of 8259A, and in that block diagram we will understand the functionality of each pin. But some of the pins we will leave because those are not the part of this discussion. For example, chip select pin, SPR enable pin, this CS0, CS1, CS2, these pins we won't be discussing, but other pins we will discuss in detail. So let's go for the block diagram of 8259A, then we will describe the functionality of each pin. Okay, so let me make the block diagram of 8259A. So in the block diagram, you can see that we have the following components. We have the data bus. We have a read-write logic. We have cascade buffer. Then we have control logic. So we will not only make the buffer diagram, but we will also explain the working of 8259A, how it works. Okay. Then we have these three blocks here. The block here. Okay. This is called a interrupt mask register, IMR. Okay, this is in service register, ISR. This one is interrupt request register, interrupt request register. So you have to remember that these registers are of 8 bits. So this is 8 bits, this is 8 bit, this is 8 bit. Okay, and every bit represents the status of an interrupt. We know that it is able to provide 8 interrupts. So status of these 8 interrupts is stored in these registers. And this one is priority resolver. This is not a register, this is resolver. Okay, and we have the communication here like this. This can communicate with this. This can also communicate with these. Okay, so from here it goes here, and these components are connected by a bus. So we have an internal bus here. Okay, so these components can easily communicate with each other. For example, the data we got from here will be placed on this bus, this internal bus. Likewise, it can receive, this can receive control signals from this bus. Okay, this will also receive the signals from this particular bus. This data bus, it is those 8 pins that we have, D7 to D0. Okay. Read write logic, so it will accept read signal, write signal. Okay, and it also accepts A0 address signal, A0 and chip select. Because see, this chip select is used if we have a memory of multiple chips. Then to which chip we have to go, that is the chip select logic. Okay. And this cascade buffer, this particular accepts 3 signals, CAS0, CAS1. Oh, sorry, these are not active low. CAS1, CAS2, and it is enabled by enable buffer and slave program pin. Fine. And this control logic, it has 2 pins. One is INT and another is I. So this means it is an input pin. So that means we are receiving some data from this particular pin. Now let's see how the operation goes on, how we can say the interrupt operation is happening. So by describing the interrupt operation, I will also describe the functionality of all these components here. Okay. So let me describe the operation, interrupt operation. So what is the operation, how it is happening? So let's say we have connected our, so this was our microprocessor 8085. And this was our interrupt controller 8259. So let's say we have connected these two together. Okay. So now let's see what is the complete procedure. We know that in microprocessor 8085, interrupts are enabled by EI signal, EI instruction, enable interrupt instruction. So what this instruction is going to do, it sets the interrupt enable flip flop in 8085. Okay. So when we are writing this instruction, after this we have to write instructions to initialize A259A controller. Okay. So that means I have to write instructions for 8085 such that it can transfer something into this. What it transfers into this, basically in 8259A, you can see that we have this control logic. Okay. So in control logic, we have the control registers. Okay. So in those control registers, this particular microprocessor 8085, it transfers some control words into its control register. Words means some data. What kind of data it has to transfer, that we have to write those instructions here. We will write, I will show you how, what those instructions are there and how we can transfer those words from 8085 to 8259. So what is the second step? Write instructions to initialize A259A controller. And what is the initialization? Initialization means we have to write control words into its control registry. Then based on those words, my my 8259A will handle the different interrupts. Okay, so see, it has to transfer data from 8085 to 8259A. How it can transfer? It can transfer from its data pins to 8259A's data pins. So this is the functionality of data bus. What is the functionality? When we have to transfer something from 8085 to 8259A or from 8259A to 8085, they can communicate via data bus. Okay, this type of communication. Now we have only seen here only one type of communication, when 8085 has to send something to 8259A, and that something is the control words. In a few minutes, we will see what type of data 8259A has to communicate with 8085. Okay, so it has to write control words into its control registry, or we can say control registers. Okay, so there are two types of control words. So one type of control word is called initialization command words. So these are called initialization command words, ICW. And another type of these control words is operational command words. Operational command, OCWs. Okay. So these ICWs, these words, or we can say these commands, are used to set up the proper conditions and specify RST vector addresses. So these words have two functionalities. First functionality is that these are used to specify, set up proper conditions. So this initialization command word, this has two functionalities. As I said, the one is set up proper conditions. Okay, so what is the meaning of set up proper conditions? For example, since we have 8 interrupts, it is able to enable 8 interrupts. It can set up the conditions. For example, whether those interrupts are edge triggered or level triggered. Okay, likewise, whether there is an interval of 8 or 4 between the two interrupt requests, whether there is a distance of 4 locations or a distance of 8 locations. Okay, likewise, whether we have a single this device 8259A device, or we have multiple 8259A devices. So those proper conditions are set up using initialization command words. The second functionality is of these initialization command words is that they are used to specify RST addresses, or we can say interrupt service routine addresses. So they are used to specify those addresses. So that means if we have interrupt 1, what will be its starting address, or starting address of it is interrupt service routine. So those addresses are also specified by initialization command words. So these are the two functionality of these command words. Now, what are the functionalities of operational command words? So they have the operations, for example, they are used to mask interrupts, provide the masking, okay, and setting up status read requests or read operations, and many more. Okay, but you have to remember that this kind of word we won't be discussing in this particular lecture. Okay, because they are not useful for microprocessor 8085. We will only discuss some of the initialization command words. We will discuss two initialization command words, one that is used to set up proper conditions and another command word to specify RST addresses. So those two we will set up. Okay, so what I said, the first part is to have this instruction, enable interrupt instruction. Then we have to write instructions to initialize 8259A controller. Okay. Then after that, what is the process? Let's go forward. So we have the following, the complete process is that up till now, what we did, that the first we have to put enable interrupt instruction. Then we have to put instructions to initialize 8259A device. Okay, so these are the two instructions that we have to put. These two. Now, after initializing 8259A, so that means our 8259A and microprocessor 8085, they have been connected, and this device 8259A has been initialized. Now comes the working. During the working, what is happening? So before discussing the working, let me discuss about these registers. IRR, interrupt request register. So what is this register doing? It is an 8-bit register. Okay, so every bit represents the status of current interrupt. For example, if this device 8259A, it is getting an interrupt. Let's suppose it is getting interrupt 2. So what it will do, it will set this bit as 1. Likewise, it will set those bits as 1 for which it has received interrupts. Let's suppose it has received 1, 2, 3, 4 interrupts. Okay, and what are those 4 interrupts? Interrupt second, interrupt fourth, sixth, and eighth. Okay, these are the 4 interrupts it has received. These 4 interrupts. Fine. So for these 4 interrupts, it will set these bits as 1 and other bits as 0. So that means it has to handle how many interrupts here? 4 interrupts. So these are the 4 interrupts. So among these 4 interrupts, it chooses 1 interrupt. Okay, and that one is that selected one is interrupt is selected based on its priority. So the highest priority interrupt is selected first. So let's say this one, the 6th position, one interrupt has the highest priority. So it will choose this particular interrupt. So after choosing this interrupt, so what is there? There is another register which is in service register. So it is also of 8 bits. Okay, so what it will do, let's suppose it has decided that it will choose this particular interrupt. It will handle this interrupt. So in this status register, in this in service register, it will set that particular bit as 1. Okay, 1 means that it is currently servicing this particular interrupt, or we can say it is currently handling this particular interrupt. And at the same time, it will make this bit as 0. Why it will make this bit as 0? It will make this bit as 0. That means it has started handling this particular interrupt. Okay, so 0 means this interrupt is not there. Why it is not there? Because I have already handled it. Okay, so what is the process? The process is the complete process is when 8259A receives interrupts, it stores those in IRR register, interrupt request register. Okay, and what it does, we have priority resolver. This particular component takes the contents of IRR, ISR, okay, and IMR. So this priority resolver, it will check this register, this particular register. From this register, it will get the information about the pending interrupts. What are the interrupts there? Okay. From this register, masking register, it will see which interrupts are to be ignored. Okay. And from this register, it will take the information which interrupt is currently handled from this particular interrupt. So based on these information, it will select an interrupt to be handled. One among these, based on these three informations, it selects an interrupt to be handled. And what it does after selecting, it sets a bit in ISR, interrupt service routine. It sets that particular bit as 1, the interrupt of which it is going to handle, and also it resets this particular bit in interrupt request register. Okay, now it has selected an interrupt. Now it has to handle interrupt. Okay, what it is going to do, it will this what is this, after selecting an interrupt, this device, after it completes the selection of an interrupt, okay, what it does, it sends INT signal to 8085. Okay, through it is this pin, INT pin, and this signal is received by 8085 through INTR pin. So we can say the INT pin of 8259A is connected to INTR pin of 8085. Okay, so that means it will send an high signal. High signal means 1. Okay, so when microprocessor 8085 receives this INTR, so what is the general procedure? General procedure is that microprocessor will send INTA. Okay, and after that, the interrupting device will either send a call instruction or RST. However, here in this particular scenario, which one is an interrupting device? 8259 is the interrupting device. It has received the interrupts from other devices, but 8085 is receiving the interrupt from this particular device, 8259A. Okay, so for 8085, this is the interrupting device. So that means when this programmable controller sends the INT signal, it goes to 8085 through INTR, and then this 8085 sends INTA signal, this INTA signal. Okay, so our 8259A device receives the signal through this pin because it also has this acknowledgement pin. After that, what this particular device is going to do, this 8259 device, it will send a call instruction. We know call instruction is like this. Okay, call instruction is opcode plus operand. So opcode is 1 byte and operand is 2 bytes. So this is the address, memory address. So it will send a call instruction. Who will send the call instruction? 8259A. Call means only this part, opcode. Okay, so this was 8259A, and this was 8085. So first job was that it will send int. So this is the first thing. Okay, and it is connected to it as intr pin. Then the second is it will send acknowledgement inta. After receiving the acknowledgement, this will send the call instruction. So 8085 will receive the call instruction and it will decode the call instruction. So after decoding the call instruction, it will understand that I will also require this address, because it should know the address where I have to go, or where is the interrupting service routine stored. Okay, so what it is going to do, it will send another INTA signal. So this was the first INTA. So on the first INTA, it has sent a call opcode. On the second INTA, it will send 8259A will send the lower byte of address. Okay, so it will send the lower byte of address. So after receiving the lower byte, it will again send INTA signal. So this was fifth, this is sixth. Why it will send again? Because now it requires higher byte also. So after receiving a third INTA, it will send higher order byte. Okay, so now my microprocessor has received call and address. Okay, so what it is going to do, it will jump to this address. At this particular address, we will be having the interrupt service routine stored, and it will execute this interrupt service routine. After completing this interrupt service routine, it will resume it as this normal procedure or normal program. Okay. Also, when my 8259A is receiving the third interrupt acknowledgement, it not only sends the higher order byte, but it does the other thing. What is the other procedure? It resets the ISA or ISR bit. So you can see here, for example, here we have said that it will set a bit in ISR for that particular interrupt. Now, since it has sent both the call instruction and its address, so that means that particular interrupt has been completed. So it will reset the ISR bit. Okay, ISR bit, resetting ISR bit means it has completed its execution. Okay, so this reset can be done by two different methodologies. One is it will automatically reset this after completing or after receiving this INTA. Okay, or it can be resetted by a command word. Okay. And this command word should be issued at the end of service routine. Okay, so there are two options, option 1 and option 2. Either it will be automatically resetted when my microprocessor will receive this INTA, or it can be resetted by a command word. That command word should be at the end of service routine. Now my microprocessor should know whether I have to apply the first option or the second option. Okay, this is done during the initialization itself. So during the initialization, we have provided the instruction command words. So from these words, we will be having done that whether it has to automatically reset or it has to reset with the help of command word. So this is done during the initialization itself. Okay. And after completing this ISR, my microprocessor will return from this particular ISR and it will continue its normal execution. Okay, so this is the complete working of 8259A in connection with 8085. So here I have shown you how this can be used to receive multiple interrupts, 8 interrupts, but the same can be made, our microprocessor can be made to work using a single INTR pin. So this single INTR pin can now respond to 8 different interrupt requests with the help of this 8259A programmable device. Now the question arises. The question arises is how we can program this 8259A device, or how we can send initialization command words to 8259. Okay, fine. And how these addresses are determined. So for example, 8259A will send the address, lower byte address and higher order byte and lower order byte, but it should know for which interrupt I have to use which type of address. Okay, so let's now see the important thing and the last part of this lecture, that is programming the 8259A device. Okay, programming means that how we are giving the ICW initialization command words to 8259A, and these words are to be given from 8085. Or we can say we have to understand what are the instructions that are used to transfer these initialization command words from 8085 to 8259A. So every initialization command word, for example, let me write 1 or 2 command words, ICW1. So let me make a command word. It is of 9 bits. Okay, so these are the 9 bits: 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, this bit is called IC4. Okay, this one is SNGL. So I am writing short form. This is ADI. Okay. This is LTIM. This is 1, always 1. This is A5, A6, and A7. And this is 0. Okay. So let me name these bits D0, D1, D2, D3, D4. So you have to remember, when we are putting the ICWs into the registry of 8259A, they have to put in the order. What I mean to say, this is the first word that is to be put, ICW1. Okay, then we have another ICW2, ICW3. They should be in the same sequence. First we should have ICW1. Okay, then ICW2, then ICW3. So what is this particular bit depicting? This one, this IC4, we don't require this bit, so let's not discuss about this particular bit because it is of no use in case of microprocessor 8085. This bit determines whether we have single or cascaded 8259. A devices. So whether we have a single device or we have multiple devices. Okay. This bit determines whether we have a spacing of 4 locations, or we can say the call address interval is 4 locations or 8 locations. So that means if I have to call someone, so let's suppose here I have stored interrupt service routine 1, and then I have stored interrupt service routine 2. So what is the difference from ISR 1 to ISR 2? Or we can say how many locations are occupied by ISR 1. If I am saying it will occupy 4 locations, so then I will use 4 locations. If I have 8 locations, I will use 8 locations. So if my ISR is 4 locations, this bit will be 1. If it is 8 locations, this bit will be 0. Okay, this determines whether it is level triggered or edge triggered. Okay, so if it is 1, that means the interrupt is level triggered. If it is 0, the interrupt is edge triggered. Okay, this is always 1. It has no significance here. These 3 bits, D5, D6 and D7, they are used to generate call addresses. The addresses that 8259A has to give to the 8085 microprocessor. We will see how we will use these 3 bits to generate addresses. And this particular bit, this is basically A0. You may have seen that in our microprocessor 8085, sorry, in this particular device, when this particular pin is 0, then only we will use the 8259A. So it is almost every time it is 0. Okay. Fine. This is one control word. Another control word that is there, it also has the following configuration. It is of 9 bits. So this is always 1. Okay. And these 8, these are called, this is called as A8, A9, A10, A11, A12, A13, A14, A15. Okay. So these bits are also used to generate call addresses. So now you can see, for example, these 2 words are mandatorily, to be there in the registry of 8259A. There are additional words, but those are optional. So we will only look at the mandatory. So you can see that from ICW1 and ICW2. So we know that we have address is of how many bits? 16 bits. So the 16 bits will be A0, A1, A2, A3, A4, A5, A6, A7, A8, A9, A15. So how many interrupts are there? There are 8 interrupts: 0, 1, 2, 3, 4, 5, 6, and 7. Okay, these are 8 interrupts. So for 8 interrupts, so for every interrupt, there will be an address, call address. Okay, so for 0, interrupt is 0, the call address is generated like this. So the first 8 bits, these 8 bits are taken from here, A8 to A15, from IC to W. Okay, so let me write it here. So these 8 bits will be taken from ICW2. So for all the interrupts, these will be taken from ICW2. So we can say all the interrupts have same these 8 bits. Okay. Fine. Then these three bits, A5, A7, and A5, A6, and A7, these will be taken from ICW1, from these words. Now comes these bits, 0, 1, 2, 3, 4. Okay, so it will be like this. So 1, 1, 1, 0, 0. Okay, sorry, it will be 0, 0, 0. Okay, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0. Likewise, it will be 1, 1, 1, 0, 0. So this is how addresses are generated for each interrupt, call addresses. But you have to remember that this is when interval is 4. However, when interval is 8, okay, let me use a different color. When interval is 8, then there is some difference. So what is the difference? The difference is this will be 0, 0, 0, 0, 0. Okay. This one will be 0, 0, 0, 0. 1, 0, 0. So these will be same, these bits, but the difference is, let me show you the difference. The difference is here. Oh, yes. Only these bits, A6 and A1, A6 and A1, they will be taken from ICW1. And these 8 bits are also taken from ICW2. So this is same. So only these bits. This A5, this one, it will be 0, 0, 0, 0, 1, 1, 1. Okay. So this is the difference between having an interval of 4 and having an interval of 8. Okay. So we have understood how these command words are used to generate the addresses as well. Now the question is how to transfer command words, how to transfer command words from 8085 to 8259. Okay. So let's see how we can transfer the command words from 8085 to 8259. Okay. So see, we have this device 8259A. It is connected to microprocessor 8085. Okay. So for microprocessor 8085, this is an input output device. Okay. For microprocessor 8085. So in 8259A, in its control registry, we have control registers. Okay. Let's suppose control register 1 and control register 2. Likewise, there will be many registers, different registers. Okay. Control register 1 is used to store ICW1. Control register 2 is used to store ICW2. Okay. Or we can say that these are stored in its memory, in its register memory. Okay. First, we will store ICW1, then we will store ICW2. Okay. So these are control register 1, control register 2. These are considered, they are here in this device. Okay. And these are considered as output devices. Okay. As output devices means that 8085 can send data to these output devices. So this control register 1 has address 80H and control register 2 has address 20H. Okay. So how I can transfer the data from 8085 into this register and into this register? What I will do, let's suppose I will do move immediate A as 76H. Okay. Then I will do out 80H. So it will take this data. What is the data in A? In A, we have 76H. So it will take this data and will give output into this port 80H. And 80H is the address of CR1. So in CR1, we will get 76H. But we know CR1 is initialization code 1. So initialization code 1 is 76H. So that means our code word was how many bits? 8 bits. This was the 9th bit. 9th bit is always 0. Okay. And others will be, these 8 bits will be 76H. Likewise, after that I will do, let's say, for example, I will do move. Oh, sorry, it is the address of CR2 is 81H. Move immediate A comma 20H, then out 81H. So now IC2 is, what is IC2? IC2 is again 9 bits, and this bit is always 1 in this, and other bits will be 20H. Okay. So this is how we move data from, how we initialize A259A by using these instructions. But before using these instructions, you have to disable interrupts. Why? Because during the initialization, our process should not be hampered or it should not be stopped by anyone. After that, you can write enable interrupts, and then you can use 8259A to receive the interrupts. Okay. So your job is that if I stored 76H in ICW1 and 20H in ICW2, what will be the addresses, 8 call addresses, and what will be the status? For example, what will be, whether there will be 4 location spacing or 8 location spacing, whether we have an edge triggered or level sensitive or edge sensitive, whether there is single or cascaded 8259, you can get this details by using these instruction, these opcodes, or we can say these initialization control words. You can convert these in binary and then use this particular figure to get the information about each bit. Okay, and then use this table to get the starting address. That is your job. Okay, so with this I will stop this particular lecture, but before completing this, let me tell you what we have discussed in this particular lecture. We discussed how we can use 8259A to handle multiple interrupts via a single INTR pin of 8085. Okay, that is the first job. The second job is we discussed the working of 8259A. We also discussed it as pin diagram and block diagram. Also the interfacing of 8259A. And lastly, we discussed the programming approach. Programming 8259. So this was the these were the contents of this particular lecture, and I hope you are able to understand all those things. So in the next lecture, like this particular device 8259A to handle multiple interrupts, from the next lecture we have another scheme called DMA, direct memory access, that is also used to handle communication with the outside devices. We will see what is this DMA, direct memory access, and we will also see one of the controller for using this DMA, or we can say we will discuss about a DMA controller. So let's meet in the next lecture. Till then, goodbye.